Ever wondered what the most mysterious and powerful objects in the universe are? Well, you're in for a treat. Today we're delving into the intriguing world of black holes, those enigmatic regions of space-time where gravity pulls so much that even light can't get out. And we're doing more than just scratching the surface, we're venturing into a scenario straight out of a sci-fi movie. What would happen if you fell into a black hole? So let's dive into the cosmic conundrum of black holes. Black holes, the enigmatic giants of the cosmos. These celestial bodies are some of the most mysterious and powerful entities that exist in the universe. They come into existence when massive stars, many times larger than our own sun, reach the end of their life cycle. These stars, having exhausted their nuclear fuel, undergo a catastrophic collapse under their own gravity, resulting in a supernova explosion. What remains is a core, a dense remnant with gravity so immense that it warps the very fabric of space-time around it. This region, where space-time is so intensely distorted, is what we call a black hole. The defining feature of a black hole, and the reason for its ominous name, is its event horizon. This is a boundary in space-time beyond which nothing, not even particles or electromagnetic radiation such as light, can escape from within it. The gravity within this horizon is so strong that it pulls everything into it, hence the term black hole. Now, this is all fascinating, but it's also quite terrifying. The thought of getting caught in such a powerful gravitational pull is unsettling, to say the least. The extreme gravity would distort time, warp space, and could rip you apart atom by atom. Now imagine if you were unfortunate enough to fall into one of these. First stop, the event horizon, the point of no return. As we delve deeper into the cosmic enigma that is a black hole, we encounter a boundary that seems to defy all known laws of physics. Welcome to the event horizon, the edge of the abyss, a place where gravity is so extreme that nothing, not even light, can escape its clutches. Imagine a waterfall with water cascading over the edge into the unknown. The event horizon is somewhat like that precipice, except instead of water, it's the fabric of space and time that's flowing in, cascading into the black hole's unfathomable depths. To an observer standing at a safe distance, the event horizon would appear as a perfect sphere, a dark void in the cosmos, the mouth of the black hole. As we approach the event horizon, time and space start to behave in peculiar ways. From the outside, time seems to slow down, but for the one approaching the event horizon, time would appear to speed up. This is due to the intense gravitational pull distorting the passage of time, a phenomenon known as time dilation. And here's the kicker. Once you cross the event horizon, there's no turning back. The gravitational pull becomes so immense that escape becomes impossible. It's like trying to swim up a waterfall that's flowing down at the speed of light. Crossing this boundary, things start to get really strange. But that's a story for the next scene. Stay tuned as we continue our journey into the heart of a black hole. Now brace yourself for a journey beyond the event horizon. As you cross this mysterious threshold, the unimaginable occurs. The gravitational pull that once gently tugged at your feet now becomes an irresistible force, stretching and pulling you in a process chillingly referred to as spaghettification. The immense tidal forces at work are like nothing you've ever experienced. Imagine the strongest ocean tide you've ever seen, then multiply it by a factor that's almost unfathomable. This is the power of a black hole's gravity. It pulls at every atom in your body, elongating you into a thin strand like a piece of spaghetti. You're not just stretched out, though. You're also compressed, squeezed into an impossibly small space. The reality of crossing a black hole's event horizon is far from the romanticized notion of a portal to another universe. Instead, it's a realm where all known laws of physics are distorted and twisted. It's a place where time and space lose their usual meaning, and existence as we know it is turned on its head. Yet, despite the terror and destruction wrought by these immense gravitational forces, there's a certain awe-inspiring beauty to it all. The infinite cosmos, the eternal darkness, the sheer power of nature, it's a humbling reminder of our place in the universe. Yet if you somehow survived this, you'd finally reach the black hole's heart. Welcome to the singularity, the center of the black hole. This is the final destination for anything unfortunate enough to fall into a black hole. The singularity is a point where all laws of physics, as we understand them, cease to function. This is because the singularity is a place of infinite density. Imagine all of the mass of a star, millions of times the size of our Earth, compressed into an infinitesimally small point. That's the singularity. Now, if you were to somehow reach this point, The extreme gravity would crush you into nothingness. This is a process often referred to as spaghettification, due to the elongated spaghetti-like form that objects take on as they're stretched and compressed by the immense gravitational forces. But here's the thing, and this is where it gets really mind-boggling. Gravity at the singularity is so strong that it warps space-time itself. It's no longer just a three-dimensional space we're dealing with, but a four-dimensional space-time. In essence, time as we understand it stops at the singularity. So inside a black hole, you'd be stretched into a strand of spaghetti, crushed into nothingness, and trapped in a place where time stands still. It's a fascinating, if somewhat terrifying concept, but from an outside observer's perspective, things look quite different. From afar, you'd appear to be frozen in time at the event horizon. Let's delve into that, shall we? Imagine you're observing someone falling into a black hole. From your vantage point, their descent appears to slow down dramatically as they get closer to the event horizon. But why? Well, it's all about gravity. You see, gravity is not just a force that pulls objects together, it also affects the flow of time. This is a concept known as gravitational time dilation, a fascinating prediction of Einstein's theory of relativity. It tells us that time ticks slower in stronger gravitational fields. In the vicinity of a black hole where gravity is extraordinarily strong, time would appear to crawl to a standstill. So, as our unfortunate Voyager approaches the event horizon, they seem to slow down and then freeze, caught in a moment of cosmic limbo. They become a ghostly image, gradually fading from view, their last moments stretched out across the event horizon. But remember, this is just how it appears to you, the observer. For the person actually falling into the black hole, time would continue to pass normally. Interestingly, their color would also change due to an effect known as gravitational redshift. They'd appear to become redder and dimmer until they eventually vanish from sight, swallowed by the insatiable cosmic beast. This brings us to the mind-bending theories of Stephen Hawking. Could falling into a black hole transport you to another universe? This question leads us to the fascinating theories of one of the greatest minds humanity has ever known, Stephen Hawking. Hawking proposed that black holes could serve as gateways to alternate universes, a concept that truly challenges our understanding of reality. Imagine this. You're tumbling towards a black hole in our universe, expecting the inevitable disintegration. But instead, you find yourself untouched, breathing in an entirely different universe where that menacing black hole does not exist. This idea hinges on the concept of a multiverse, where our universe is just one of countless others, each with its own unique laws of physics. In some of these universes, black holes might not even exist. In others, they could be as common as stars are in our own. Hawking's theories also suggest that black holes could lead to universes where time runs backward, or where the laws of physics are so alien that our human minds can't even begin to comprehend them. However, these are just theories, mind-bending and unproven. They serve as compelling reminders of how little we truly understand about the cosmos and how much more there is to discover. So, while a trip into a black hole might be a one-way journey in our universe, in another, you might just come out unscathed. In the end, black holes are as fascinating as they are terrifying. These mysterious entities, born from the collapse of massive stars, exert such potent gravitational pull that even light cannot escape. Journeying into one, you'd confront the event horizon, the point of no return, succumbing to the extraordinary tidal forces that would stretch and tear you apart. And if you survived, you'd meet the singularity, where gravity is infinite and your existence would be crushed into oblivion. Yet, from an outsider's perspective, you'd appear to slow down, dim, and eventually freeze in time at the event horizon. An intriguing paradox indeed. Stephen Hawking's proposal of alternate universes further stirs the pot of cosmic conundrums. Could you fall into a black hole in one universe and continue to exist in another? So next time you gaze at the stars, remember the cosmic mysteries that lie beyond